The RDSO guidelines, BS 96, primarily deal with the underwater inspection of bridges on Indian railways. The guidelines specify the necessity, frequency, and methods for inspecting the submerged portions of railway bridges that are perennially underwater. Also, there is one book of IRICEN, which is a good resource on the subject matter. The underwater inspection of bridges is required 1. To ensure safe condition of substructure during the service life. 2. To detect any distressed condition of substructure, outlived or premature. 3. To prevent any possible mishap due to structural failure by taking timely action. The RDSO guidelines BS 96 prescribe a systematic, three-tiered approach to the underwater inspection of railway bridges, with each level increasing in complexity and triggered by different conditions. These inspections are vital for detecting hidden damage and ensuring the long-term safety of the structure. There are three levels of inspection specified. Level 1, the routine swim-by inspection. The process begins with a Level 1, or routine inspection, which must be performed by an experienced diver annually, especially after the monsoon season. This is a general swim-by assessment using visual and tactile methods, where the diver sweeps their hands to feel for abnormalities in murky water conditions. The inspection team, guided by an experienced leader, focuses on identifying obvious and major damage. Key tasks include checking the depth and assessing scour, erosion around the piers and abutments, confirming the physical continuity of the pier structure, recording signs of spalling, flaking concrete, corrosion, and any cracks larger than 0.2 millimeters. The report for a Level 1 inspection documents the overall condition, any deficiencies, in the condition rating of the underwater components. If this inspection reveals any problems or produces inconclusive results, it may trigger a more detailed examination. Level 2. The detailed inspection. A Level 2 inspection is a much more thorough examination performed once every 5 years or whenever a routine inspection indicates a potential issue. The key difference at this level is the selective cleaning of marine growth from sample areas to allow for a detailed surface inspection. The dive team uses tools like clear water boxes and water jets to clear the surface of marine organisms, concentrating on specific zones like the waterline, mudline, and construction joints. The inspection itself involves more precise measurements and detailed documentation of any detected deterioration, including spalling, cracks, or corrosion. The aim is to quantify the extent and severity of the damage. A Level 2 inspection is warranted for critical or unique structures, those with a history of distress or in adverse environmental conditions like polluted water. The findings determine if the damage can be repaired based on existing data or if an even more specialized investigation is necessary. Level 3, the special investigation. The highest level of inspection, a Level 3, is a detailed, focused investigation of specific components. It is only undertaken when serious damage is suspected, such as after an unusual flood, vessel impact, or significant earthquake. The purpose is to comprehensively assess the type, extent, and cause of the damage to inform a repair strategy or potential load restrictions. This is a highly technical process that goes beyond visual checks. It involves extensive cleaning and precise measurements. The use of non-destructive testing (NDT) methods to determine material strength and detect internal flaws. Examples of NDT include ultrasonic testing and concrete coring, a thorough analysis of material strength and homogeneity. The results of a Level 3 inspection are crucial for determining the structural integrity of the bridge and formulating a detailed rehabilitation plan. It provides the necessary data to decide on emergency measures, such as imposing speed restrictions or closing the bridge to traffic. Now let's discuss the methods used for conducting underwater inspection. Scuba diving utilizes self-contained underwater breathing apparatus, scuba. Diver breathes compressed air from scuba tank, suited for short duration, high mobility dives. Surface supplied air diving, air supplied through umbilical hoses from surface compressor tank, ideal for long duration, deep dives in high flow, velocity waters. By RORV, underwater inspection with remotely operated robotic vehicle. For the benefit of our viewers, I am enclosing PDF copy of these guidelines in the description and comment section. So this was all about the current topic. Let me know the topic on which you want to watch a video. Subscribe all about bridges for more such content.